Hey, Bogdan Wrzewski here. Another video, linear functions. In this video, we'll show you how slope, intercept form, and standard form are connected. What is the significance of both form of the equation of a line? So let's dive in. So quick review. The most commonly used equation of a line and slope y-intercept form looks like so. Y is equal to mx plus b. Maybe you're familiar with that or not. If this is the first time, so let be it, and let's go over those the meaning of those letters. So this is the direction of the line. This is the positive or negative or zero value. Those are the possible numbers. B is the y-intercept, because every single linear function has a y-intercept, zero, negative, or positive real number. So then you have an equation that looks a little bit differently. So you have integers in the statement, and you have ax plus by plus c is equal to 0, where both a and b cannot be equal to 0 at the same time. Because if they were both 0, then the linear function would not exist. Because you would have a statement c is equal to 0, and when c is, let's say, 4, then 4 is not equal to 0, so a contradiction. So a and b are not equal 0 both at the same time. Individually, yes. C can be 0 or any positive or negative integer, right? So those are the possibilities. And they both, those two different forms represents the same line, but the appearance is different. So in this example, we will convert standard form into slope y-intercept form. In order for it to happen, we would have to think of this statement like so. My goal is to isolate for y somehow. But if y term comes with coefficient b, then to make one y, you would have to divide every single term of the equation by b. So imagine you hold by on the left side and move ax and move c term over to the other side. Then you divide both parts, left side and the right side, by b to make single y equal to the new expression. So this negative a over b obviously would represent slope of the line. And the ratio negative c over b would represent the y-intercept for that line. So hopefully that makes sense. And also, for some of you, when you study lines and algebra, linear algebra and vectors, you would make the connection that if there is a line, the vector which is perpendicular to the line would come with coordinates, and a and b are the coordinates of that normal vector which is perpendicular to the line. But that is later discussed in the later videos when we do linear algebra. So, particular example with numbers. My coefficient a is 3, b is 4, c is negative 5. So this is the standard equation of a line. Changing into the slope form follows the same procedure. Isolate for y somehow. So move things around. Keep the 4y term, move 3x and move negative 5 over to the opposite side, then divide everything by 4 to make 1y. So there you go. 4y divided by 4. Negative 3 over 4x and 5 over 4. So the slope is negative 3 over 4, and the y-intercept is positive 5 over 4. So this is the example of a line with negative slope. So the line is declining as you read the graph left to right. There is a y-intercept at 5 over 4. And this is pretty much what you get from that slope y-intercept form. Standard form, for now, if you just have that equation in front of you, you may not see much, but you will see how to find x and y-intercept in a moment. Just give me a second. Let's convert back the slope form into standard form by rearranging what we have in front of us. Let's say you have this to start with. you observe the following. You have a denominator. You don't have to have a common denominator, but you have to find a common multiple if denominators are different, so that when you multiply the entire equation by that common multiple, you will eliminate the denominator. So since this is only out of 4, so times 4 every single term. So when you multiply an equation, you multiply every term of that equation by the same non-zero values. So that's why you get 4y because of this product. Negative 3/4 times 4, 4 cancel because you're in the process of division, so you get minus 3x, and 5 over 4 times 4. If you were to multiply this, would be 20 divided by 4. It is 5, so bingo, you have it. So, and then you don't want to leave it in that form because you want to keep ax first, by second, and c as a third expression. So you change the order of appearance and you have a beautiful equation which is identical with the one that we started this exercise with. So both forms are interchangeable. You can convert one into another, no problem. Now, so knowing that this is the same line from the slide above, negative slope. So this is just a quick sort of summary. Slope could be negative or positive. So that's given. And the y-intercept is negative, positive, or 0. Same for the slope. That is given. And we need to understand how that impacts the direction of the line and where the line cuts y-axis. Now, if a line intersects y-axis, most of the line, except for the horizontal line, also would have x-intercept. So there is a way of finding x-intercept and y-intercept using a standard equation of a line. So let's say we have the same equation again to work with that equation to find x and y-intercept. So the idea is to move constant over to the other side and divide both sides of the equation by that constant so that you can create 1. Once you have 1, then you see isolated coefficient of y and x points directly into x and y-intercept. So if you divide this by 5, right, so you get 3 over 5x, divide by 5 to get 4y over 5 is equal to 1. So hopefully that makes sense. Now, to make it by itself letter y and x, you have to be mindful how you divide fractions so that this denominator, 3, is below 5. So x divided by 5 over 3 is the same as 3x over 5. So you have to be skillful with fractions. If you have forgotten, watch my other videos so that clarifies for you. Same thing here. You have identified 2 points where those points are represented correspondingly to the y-axis in case of 5 over 4 and x-axis. So those are the x and y intercept. Now, if I want to use this standard equation in a slightly different manner, I have to be aware of the following. X-intercept means y is equal to 0. So imagine this is 0, and you're solving the new equation for x. So 3x plus 0 minus 5 is equal to 0. Because of the x-intercept, y is gone. You're solving it for x, and you get 5 over 3, which is the same as this one, right? It must be the same. For the y-intercept, you say, okay, I know where that is on the y-axis, so x is equal to 0. So imagine this is gone. 3x is gone from this equation, so 0 plus 4y minus 5 is equal to 0. Solve it for y, and y is 5 over 4, and you know it, that this is the y-intercept. So now you know how to find x and y-intercept using standard equation of a line. Another example quickly where we have a slope of a line given and the point. And the challenge is to find 2 forms of equation of the same line because the slope must be maintained and it is, and that point of interest on the line pinpoint the location. So there is no way that there is two possibilities, one line, one unique line. So if the slope is 1/3, you can use that slope y-intercept form directly and plug in the value of m into this equation. Now, point B you can do in two ways. You can plug in for x and y directly into that equation and then solve it for B, or you can use this beautiful equation, slope point form, that really comes from the origin of the linear equation of a line and slope y-intercept form. Why is that? Because y minus y1 divided by x minus x1 truly represents the slope of a line. And then you rearrange that equation to show this is equal to the product of m times x minus x1. Knowing what the slope is, it is 1/3. I substitute directly to the equation y is equal to 2. So bingo, we have y minus 2. And x is equal to -2. This is the easy mistake that you make for not being careful enough. So the formula says x minus whatever x you have. So x minus -2 is +2. So now you're at this stage. All you need to do is to rearrange and so that you're going to show y is equal to mx plus b. So 1/3 x multiply 1/3 times 2 is 2/3. And that -2 you move over to this right side. So this is why you have 1/3 x plus 2/3 plus 2. Your job is to add those two things. This is your y-intercept. So 2/3 plus 2, 6/3 plus 2/3 is 8/3. Bingo. No decimals, exact value. So this is my equation of a line with slope 1/3, passes through the point -2 and 2 in that y is equal mx plus b form. Now, to create a standard form, you can use that proportion and say, now I know that slope is -a/b, the y-intercept is -c/b. You can use the equivalent fractions, and if I were to make this fraction is equal to 1/3, if I say that b is equal to 3, then a is equal to -1, right? So that would give me equivalency. So one idea is this, or you can say, no, this is too confusing. Just work with what you have. Mx plus b is probably the safest bet. You can multiply both sides of the equation times 3, and you're going to get positive 3y, 3 times 1/3, and 3 times 8/3. So when you multiply them together, and you would rearrange so that you have ax as a positive integers, by could be positive or negative, c could be positive, negative, we don't care. But coefficient a has to be positive, so you change this equation into that form, and you still have a standard form where you have this slightly altered than I mentioned at the beginning, ax plus by is equal to c. Personally, I prefer ax plus by plus c is equal to 0, but it doesn't matter really because they both are equivalent. So there you go. We were able to create equation of a line given the slope, given the point of the line, using the standard form or using the slope form. Now you're a master of those two forms and you understand that they look different, but they represent the same line. All right, one more equation to create. We have a point. And then we have another point that this is a very unique point, y-intercept. So let's see how we can create slope form and standard form. So slope form, mx plus b, the most familiar with many of us. So I don't have a slope, but I have a y-intercept, so take advantage. Substitute 8 with b right here. Knowing that x is 6 and y is 1, you can do the replacement right here. Y is equal to 1, x is equal to 6 plus 8. So the only variable standing is m. So solve that equation for m. So welcome back to solving linear equations. So 8 and 1 combine. So 1 minus 8 on the left side is equal to 6m. Now you have to divide it by 6 to isolate for m. So this is the choice, y divided by 6, so that you can make 1m. So divide both sides by 6, and you have negative 7 over 6 is equal the slope. So the slope is negative, so the equation of a line now can be written as y is equal negative 7 over 6 plus 8. So that's the one form of the equation, standard form. Ta-da! Multiply everything by 6, right? Because that's the only denominator standing. You want to get rid of that. So times 6, the left side, times 6, every single term on the right side. And then you do multiplication, so 6y, obviously, negative 7x, because the 6 and 6 in the process of division, they cancel each other out, so negative 7x, and plus 748, because 8 times 6. All right, so this is incomplete. You have to go with ax plus by is equal to c statement. So the first one is a, so 7x on that side is positive. Copy the 6-1 because it's already on the left side, and the right side remains with 48. So hopefully this makes sense. You can create any form of an equation given 2 points, given one slope and a point. You have to have at least 2 points given in order to create a standard form or slope form. And practice question is the must, at least in my books. You watch the video, you understand. Hopefully you like the video so you can share it. But don't forget to do these practice questions. We'll see you next time. Bye for now.